Here in the I button and in description box below, you will get the complete playlist of complex numbers. Welcome to video number 3, and in this particular video we are going to discuss about different forms of complex number. So let us start. The first form of complex number is Cartesian form, or we can say rectangular form. So the first is Cartesian or rectangular form. We have z equals to x plus I y. This form of complex number is called Cartesian form, or we can say this as rectangular form, where x and y both are real numbers. Okay, this x and y both are real numbers, but this part is real part and this part is the imaginary part. Okay, let us plot x-axis and y-axis. This is x-axis and this is y-axis. What we are trying to represent is Cartesian form. Okay, so this is Cartesian form representation. Okay, in this x-axis is known as real axis. Okay, this x-axis is known as real axis and this y-axis is known as imaginary axis. This y-axis is known as imaginary axis. Suppose we have a point P here. Okay, this point is the origin O. Fine. Now suppose this point where the coordinate is x comma y. So if you plot this, if you project this point onto the x-axis, this distance will be x, and if you project this point P on y, this distance will be y. Okay, so this is x, this is y. So complex number z is given by x plus iy. Okay, here we have a node point, that is the plane on which we have drawn this real axis and imaginary axis is known as argand plane, or we can say complex plane. Let me write this. The xy plane is called argand plane, or we can say complex plane. Fine. So we have drawn this imaginary axis and real axis on this argand plane, or we can say complex plane, where the complex number z is given by x plus iy. Fine. Now we'll come to the second form of complex number, that is polar form. So number 2 is polar form. Fine. Let me draw this x and y axis again. This is x axis and this is y axis. Okay, this is the origin O. Suppose we have a point P which is at a distance of r from this origin, and this angle, suppose this angle is theta. Okay, this distance is r. Fine, this distance is r and it is this angle made with the x-axis, or we can say real axis, is theta. Fine. Now if you project this on x-axis, this distance would be r cos theta. In the same way, if you project this point onto the y-axis, this distance would be r sine theta. Fine. I am repeating this once again. We have this real axis, this is imaginary axis. We have a point P which is at a distance of r from this point O, which is subtended by an angle theta with the x-axis. On projecting this point onto x-axis, you will get the distance as r cos theta. If we project this point onto the y-axis, you will get this distance as r sin theta. Okay, so here we can say what is x, that is r cos theta, and what is y, that is r sin theta. So here we have x equals to r cos theta, fine, and y equals to r sine theta. Now since we know that is z equals to x plus I y, what is x, that is r cos theta, plus I, what is y, that is r sine theta. Now what we can do is we can take r common from both the terms, that is r into cos theta plus I sine theta. Okay, this is what, this is z, and this is known as the polar form of z. So this is known as the polar form of z, fine. Now here we have a note point. What is the note point? That is polar form of complex number can also be written as r angle theta. Okay, and we are going to discuss this r and theta in the next video in detail, fine. Now after this we'll come to the third form of complex number, that is exponential form. Third is exponential form of complex number. Exponential form, fine. Here e to the power I theta is known as, or we can say e to the power I theta is equals to cos theta plus I sine theta. Okay, now here in the polar form of z, we have z equals to r times cos theta plus I sine theta. So using polar form of complex number, we have z equals to r bracket open cos theta plus I sine theta. This is equals to e to the power I theta. So we can say r into e to the power I theta. What is this? This is z, and this is what, this form is known as exponential form of complex number. So we can write this as, this is the exponential form. Okay, we can say this as Euler's form of complex number. Okay, this is also known as, or we can say this is also known as Euler's form of complex number, fine. So this form is known as exponential form, or we can say Euler's form of complex number. Now we'll come to the very important note point, that is, yes, here we have e to the power I theta, that is equals to cos theta plus I sine theta. Okay, suppose you want to find e to the power minus I theta. In that case, in place of theta we will put minus theta. So cos of minus theta plus I sine minus theta, fine. Now we know cos of minus theta is cos theta and sine of minus theta is minus sine theta. So this is going to be cos theta minus I sine theta. Okay, suppose this is my equation 1 and this is my equation number 2, fine. So what we'll do first is we want to find cos theta and sin theta. If we want to find cos theta, then we will add equation 1 and 2. So here we can write, here we are going to write on adding 1 and 2, what we will get, cos theta plus I sin theta plus cos theta minus I sin theta. I sin theta will get cancelled. What is left? That is 2 cos theta. So here we can write 2 cos theta is equals to e to the power I theta plus e to the power minus I theta. So here we can write e to the power I theta plus e to the power minus I theta. So you will get cos theta is equals to e to the power I theta plus e to the power minus I theta upon 2. Okay, this is an important result. Okay, now again we want to find sin theta. In that case we will use 1 minus 2. Okay, so similarly 1 minus 2 gives what you will get. If we do 1 minus 2, then cos theta will get cancelled. This minus of this, that is I sin theta, minus of minus I sin theta will become twice of I sin theta, that is equals to this minus this, that is e to the power I theta minus e to the power minus I theta. Fine. Now we can find sin theta from this. Okay, that is e to the power I theta minus of e to the power minus I theta upon 2i. Here we have 2i, so 2i is in the denominator part. Now again this is also an important result. So cos theta is equals to e to the power I theta plus e to the power minus I theta upon 2. What is sin theta? That is e to the power I theta minus of e to the power minus I theta upon 2i. And both the results are very, very, very important. Okay. So thank you so much for watching this video.